Okay, so as I said before, we're going to be talking about volcanoes. So I have an agenda for you guys here of what we are going to go through for today's session. So first of all, we're going to be talking about what volcanoes are. So what are volcanoes? I know many of you have seen them, but I'm sure that many of you don't actually know how they're created, what they are. Okay, so that brings us to our next topic. We're going to be talking about how volcanoes form, the formation of volcanoes. Then we're going to go in and transition to volcanic eruptions. Then we're going to be talking about some of the nitty-gritty, some of the chemistry behind it. Okay, so we're going to be talking about physical changes. We're going to be talking about chemical changes. And finally, in the last session, we're going to be doing a volcano ourselves. Okay, so in the next session, look forward to that. We're going to be creating our own volcano. Okay, and I'll tell you how that differs from a traditional volcano. So, what are volcanoes?
Rocks with lava in them.
Rocks with lava in them. I love that. Does anybody else have a different answer? Does anybody else want to add on to that? Aura?
I think volcanoes are something which are they're also dangerous, and they give out red lava, which only volcanoes give, not any other thing gives.
Yeah, awesome. So you off the bat, I noticed that you guys are observing, you guys are looking at from the video what you saw, from your own observations what you saw, and you guys are making those connections, which are wonderful. Okay, so what are volcanoes really? So volcanoes are essentially, if you think about it, they're just openings in the Earth's crust. Okay, so they're literally just openings. Okay, so volcanoes are formed when these tectonic plates are pulled apart and pushed together. And I'll tell you what tectonic plates are in just a second. So the Earth's surface is made up of a hard crust. Okay, so this hard crust is what actually forms our land, it forms our seabed, and all of the aspects of the Earth that we have is formed by this crust. Okay, so beneath the crust, this is when it gets interesting. Okay, so beneath the crust, it begins to get very, very hot. Okay, so that hot rock turns into what we know as magma. So you guys all told me already. You guys already know the terms. You guys already told me what magma was, and you said that there is magma. But did you know that magma actually exists beneath the Earth's crust? Did you guys know that? Yeah. Yeah, so it gets very hot down there. Okay. So when volcanoes erupt, magma, along with hot ash and gases, are going to escape. Okay, so when volcanoes erupt, essentially everything that's down there is going to start funneling up. It's going to go upwards. Okay, so that brings us to our next topic. How do volcanoes form? Does anybody have an idea on how volcanoes form? Have you guys ever wondered that?
I think I have an idea of why volcanoes, how volcanoes form.
Sure, Iman. Let me know.
It's when magma is trying to get out of the Earth's crust. So that is how volcanoes are formed. All the land just goes up.
I like where your head's at. You're thinking along the right lines. That's
yeah,
good.
it's hard to explain.
Yeah, it's really hard to explain. I bet even I struggle with it. Does anybody else have any other? Oh, Wara?
Yes. How do volcanoes form? I think the rocks which are beneath the Earth's crust. So because there's a mantle after the crust, so there's like a hot. So I think there's like a lava or something which like the rocks turns into magma, and which gives like the heat and like a lot of pressure. So it just like bursts up cracks open the crust, and then the lava just comes out of the Earth. I think so.
Wonderful. All of these are great answers, and you guys are great scientists because of your reasoning. Okay, and that's exactly what scientists do. That's wonderful. So how do volcanoes form? So that brings us to our previous term that I introduced you to, tectonic plates. Who remembers that term, tectonic plates? I told you guys about it just a slide ago, right? So tectonic plates, I promised you that I'd tell you what it means too. So tectonic plates are these hard slabs of rock that make up the Earth's crust. Okay, so they're these huge slabs of rock that make up this crust that we have as Earth, right? So volcanoes are formed when the Earth's tectonic plates, so these hard slabs of rock, they're like this, right? So they're formed when the tectonic plates are either pulled apart or pushed together. So can you imagine two tectonic plates like this being pushed together ever so slowly? Eventually, what's going to happen?
It's going to form a rock.
Good, it's going to collide and it's going to form a rock. And which way is this going to go? If it goes this way, which way?
It's gonna go upwards.
It's going to go upwards, exactly. So if you bring your hands together like this, at the point where they meet, you notice that you're going to start going upwards, right? And that's exactly how these volcanoes are actually formed. Okay? So here I have a picture of the tectonic plates, a rough approximation of the different tectonic plates that we have on Earth. So if you notice, all the continents are actually formed on top of tectonic plates. So who's heard of the term Pangea?
I have.
You have, Santiago. Do you want to tell me what that
Yeah.
means, Santiago?
Yeah, it's when the whole world was together instead of being like different continents.
Yeah, wonderful. Great answer. So at one point in time, the Earth was actually one major supercontinent. Who knew that? All of you guys knew that? Some of you guys didn't know that? Awesome. So you guys have learned something. So at one point, all of the continents were actually joined together as one. And there's actually proof for my proof behind this. So if you notice, if we look at the continent of Africa here, right? Then we look at South America. Do you notice that Africa and South America, if I kind of brought them together, do you notice how they would kind of fit roughly like a puzzle piece? So I'm gonna get my drawing out here if I can. So here's South America and here's Africa. Do we notice how that would fit over there? Yeah, everyone sees that? So just like that, at one point, they were all a supercontinent, okay? And the point being here is that these tectonic plates are constantly moving, okay? So that doesn't mean they're moving extremely fast. They're moving very slow, actually, okay? So these tectonic plates are constantly moving, and that's exactly how these volcanoes are formed, okay? So when they collide, or when they're pushed or pulled apart. So our next question is, why do volcanoes erupt? Why do volcanoes erupt? Well, the movement of the tectonic plates, again, we're coming back to this, right? So the movement of the tectonic plates causes the magma to rise to the surface at these craters or holes, okay? So when these tectonic plates are moving, the magma is rising to the surface of these craters or holes, okay? And when the magma rises to the surface, what do we get? The volcano erupts, okay? So the thing about magma is it's kind of interesting, okay? So magma can either be very thick or it can be very thin, okay? So thin or runny magma erupts through openings in the Earth's crust before flowing onto its surface as lava, okay? And if the magma is thick, the gas bubbles, they can't easily escape, okay? So they can't easily escape, and the pressure is going to continue to build up, okay? And the pressure is going to continue to build up until the magma keeps rising, and these are what result in the more dangerous volcanic eruptions that you see on TV, the explosive ones, the ones that go boom and all the lava's flying in the air, okay? So the thick magma is actually what causes this, okay? And I want you guys to try it on your own. So here we have a picture of a thin magma, and here we have the thick magma causing explosive eruptions. Yeah, Luna.
I also think that volcanoes, when they erupt, they may cause an earthquake because of the loud noise they make. They might cause an earthquake to happen.
Yeah, you bring up a good point. So sometimes if the volcanic eruption is so powerful, it can cause quite often it can cause the tectonic plates to shift, right? And this could result in earthquakes as well.
That's the reason you can't really live near them, because it can be really dangerous.
Yeah, a lot of them are actually on fault lines, and fault lines are exactly where earthquakes are more likely to happen, okay? And a lot of them are on fault lines because remember I told you that volcanoes tend to form where two tectonic plates meet. And that's exactly where our fault line lies. Okay? Wara?
Also, like in the photos, as I noticed that the thick lava when it erupts, so it causes like a lot of carbon dioxide, like a lot of black smoke, while the thin magma, it's because it's runny, so it doesn't cause like a lot of smoke, I think.
Yeah, you're right. You're completely right. So as the pressure builds up and the gases continue to build up, you're more likely to get that black ash come into the atmosphere in a more heavy manner. Okay? And I actually want you guys to try this. This brings us to a good transition point. Okay? So, yeah, Luna, before we do it, do you have a question?
Yeah, I have a question. What makes the volcano have thick lava sometimes, and what makes it have thin lava sometimes?
So different volcanoes actually have different properties. Okay? So depending on where the volcano is, the composition of magma underneath the surface, underneath the Earth's crust, it can all be contributing factors. Okay, so volcanoes that are present in different places on Earth will have different compositions of lava inside of them, under the crust, sorry. Okay, so I want you guys to actually try this too. If you don't have a glass of water and a straw on hand right now, you can even imagine it. Okay, so we're gonna get a glass of water, we're gonna grab a straw, and we're going to use the straw to blow bubbles into the glass of water. What would happen?
Bubbles will start to form, and can hear the noises.
Yeah, you get those noises, the bubbles would start to form. That's great. That's a great analysis. So does this happen very easily when you blow into it? Do you get bubbles very quickly? Okay, great. Note that. Okay, so bubbles are very easily formed. They can escape quite easily because the water is very thin. And that brings us to our first term. It's not viscous. Okay, so it's very thin. It's runny. It's not viscous. Okay, when something's viscous, it's thick. Okay, so our next scenario that I want to do is now get a jar of jam or honey, and then we're going to use another straw. We're going to put that straw into the jar of jam or into the jar of honey, and we're going to blow into it. Now what do you notice?
It'll be harder to form bubbles.
It's much harder to form bubbles. Good, Luna. And Wara?
Actually, so when you, like, if there's water and if you blow with the straw in the water, like less of your energy will be used, so like less pressure. But if you do it like in a honey, so if you blow into it, so it will be like more energy and you have to give more pressure to it. So,
yeah. Exactly. So it requires more effort on your part and it's much harder to do. So this is partly because of the fact that the jam and the honey are very viscous. They're very thick, right? So they wouldn't move much at all if you tried to pour them. So if we try to pour water and jam, what's going to reach the ground first?
Water.
Water. Wonderful. Because it's not viscous. Okay? Whereas honey or jam is very viscous. Okay? And this is exactly the properties that magma resembles, right? When it's thick, there's more pressure that builds up. When it's thin, it's less pressure.
Also, can I say something? So, when you like boil water, so the bubbles are like fast, and so they are like quickly erupt. So they're quickly like going in, like going out. But if you do it like with a honey or something else, so it might take time for them to boil and stuff, and the bubbles won't like be quick. I think.
Exactly. Great. So there's our water, blowing bubbles with water, and there's our honey. Very viscous, very thick. So remember our key word that we just learned, viscous, viscosity. Okay, so viscosity is referring to how thick something is, how hard it is to pour. Okay, if something's viscous, it's harder to pour. So that brings us to our next term in chemistry, physical change. Okay, so a volcanic eruption is actually considered a physical change. Okay, so what is a physical change? Now that you know that a volcanic eruption is considered a physical change, can you tell me what a physical change is? Wara?
I think a physical change is something which is like physically done, like a volcano. Also, like the land just bursted up and then the magma turned into lava. So I think it's a physical change. That's why, because something which is like being like doing some work which is coming up, so maybe.
Yeah, wonderful. So I love where your head's at. You're thinking along the right lines, and that's great. Okay.
I have an idea.
Yeah, Iman, do you want to share your idea?
So for example, imagine you're playing with a small stack of Play-Doh and you just shape it into random stuff. That is physical change. That is just temporary. You could just shape it into a ball, shapes, sizes, whatever. That is a physical change. You have to touch it, you have to move it. That is physical change.
Wonderful, great. Iman, I like that you used the word temporary as well, okay? And I'll tell you why in just a second. So a physical change is the change in which the composition of the substance remains unaltered. So just like Iman told us, so playing with the Play-Doh, for instance, right? So when you make different shapes with the Play-Doh, is it still Play-Doh?
Yes.
Yeah. At the end of the day, it's still Play-Doh, right? So the substance that you started with is still the same. It's remaining unaltered. Even though you change the shape, right? You might make a horse first with the Play-Doh, and then you might make a monkey with the Play-Doh, right? So even though you change the figure, it's still Play-Doh, okay? So in a physical change, no new substance is formed, okay? So there's nothing new that's formed. We still get our same old Play-Doh, okay? So melting ice is an example of a physical change. Why is melting ice an example of a physical change? Does anybody want to tell me? Give me the reasoning. Luna?
Because ice is made of water. When it melts, it's still gonna stay water. It's not gonna change.
Wonderful. Can I bring water back to ice?
Yeah.
What do I have to do?
Freeze it.
Freeze it, exactly. And it's still going to remain the same thing. Okay? That's my point here.
How about when it evaporates? Is it still gonna be a physical change?
Yeah, there's actually a way in which we can bring it back to water. Okay? So, can anybody else think of another example of a physical change?
I think I have an idea for another example.
Yeah, Iman, share it.
When you are ripping a piece of paper or tissue.
Yeah, exactly. That's a great example of physical change. Okay? Or when I break a match in half, that's a great example of physical change. It's still a match. Okay?
Exactly.
Now, let's take that one step further. So what if I lit that match on fire? Is it now a physical change? Is it still a physical change?
No, because if you light that match on fire, that match would get burned and you can't turn that back to normal wood. That is called chemical change. It's not temporary, it's permanent.
Exactly, wonderful. So that is what we refer to as a chemical change, okay? So it's not reversible. Luna and Maura after.
Crushing a can is also an example of physical change.
Crushing your can is a great example of physical change. Maura?
Can I tell about chemical change?
Yeah.
If a metal thing gets rust on it, so basically rust is with water and air. So I think that's a chemical change.
That's a great example of a chemical change because there's two reacting to make rust, okay?
Yes.
So a chemical change is when you get a change in the starting substance and the production of a new substance, just like all of you guys have already told me. Okay, so you get a change in the starting substance and you get the production of a new substance, okay? So chemical changes are irreversible, meaning you can't go back for the most part, okay? So chemical reactions are a process in which a chemical change occurs, okay? So for example, when I'm making a campfire, I'm burning firewood, right? When I'm burning firewood, it turns into ash. I can't re-burn that firewood. I can't burn it again, okay? So we're gonna skip through this and we're gonna talk about, we're gonna do a little quiz. So boiling water, is that a chemical change or a physical change?
Physical change.
Physical change, wonderful. Breaking a match in half, is that a physical change or a chemical change?
Yeah, it's a physical change.
Physical change, wonderful, Santiago. Lighting a match on fire.
Chemical change.
Chemical.
Ishal? Sorry, I couldn't hear you, Ishal. Wonderful, great job, Ishal. Round of applause for Ishal. Wonderful. Chemical change. How about, this is a cool one. How about Mentos and Sprite? Who's seen that experiment on YouTube?
I
I'm sure all
have
of you
1,000 times.
1,000 times. Yeah, exactly. People put Mentos in Coca-Cola all the time, right? Is that a chemical change or is that a physical change?
Chemical change.
Physical.
Chemical.
Wonderful. Chemical change. Why is it a chemical change?
Because
You have.
are coming together and it's for permanent. You like both.
Yeah, exactly. So it's gone. The Mentos is gone after. Okay, the Mentos
Yeah.
has been used up. Okay, so our last slide that we're going to talk about today is we're going to relate all of what we just learned back to volcanoes. Okay, so volcanic eruptions, are they a physical change or a chemical change? What do you guys think?
They're a physical change.
Why,
Not
Laura?
physical.
Because I think physical because they're like actually I think it's chemical change because magma is turning into lava and then we cannot bring lava again because then lava turns into granite and then we cannot bring it again into lava. That's why maybe.
Okay, interesting answer, Laura. Luna?
I think it can be both. Like the rocks on it is physical because it can re-erupt again. But the lava and magma, they won't be the same ones that were used in the first eruption.
Okay, so I
So
see some interesting
The magma is a chemical.
Okay, so we're a little split on this. We're not really sure. Okay, but a real volcano actually undergoes a physical change. I know it's a very complicated one, and it can arguably be both. But when we talk about the eruption, it's mainly physical. Okay, so why is it? It's because eruptions occur when molten rock that's called magma rises to the Earth's surface and builds up pressure, right? And when the pressure is high enough, the volcano erupts, releases water, water vapor, lava, and carbon dioxide, right? And once it reaches the surface, we now call it lava. Okay? So it's a physical change in that sense, right? There's nothing new that's being made, there's nothing that's used up. Okay? But now for next week, before I hand it off to Miss Charlotte, for next week, we are going to be talking about a chemical change. Okay, we're going to be doing our own volcano and we're going to be looking at a chemical change. And I'll tell you why that's different from a real volcano in the next class. Okay, so thank you guys for coming. And just for next week, be excited because we're going to make our own volcano and I'm going to tell you guys exactly how that differs from a volcano here on Earth. And we're going to relate it back to physical and chemical changes. So remember what you learned today.
You have any further questions, please call or email us. We hope to see you in our online world of learning. BrightMinds Online School can help you achieve your academic goals. Visit us at brightmindsonlineschool.ca or call us at 647-931-9070.